Alright, here's another example from your book. This time, this is a mass to mass Stoich problem. Alright, and it says chloroform, CHCl3, which is an important solvent, is produced by a reaction between methane, CH4, and chlorine. And then it gives you the balanced chemical equation. How many grams of CH4 are needed to produce 50 grams of CHCl3? Now, I'm going to do all steps of stoichiometry together. Step 1. Convert to moles. So I have only one number in the equation that it gave me, and it gave me a mass. So I have 50.0 grams of CHCl3. If I have grams of CHCl3, I have to have grams of CHCl3 on the bottom. And step 1, I'm converting to moles, so I'm going to do moles of CHCl3 on the top. And just like all the mole conversions we did previously, it's 1 mole of CHCl3. And the number that goes here is the mass of CHCl3. So carbon has a mass of 12.011, and I need to add the mass of hydrogen, 1.008, and then I have to add to that the mass of chlorine 3 times. Chlorine's mass is 35.453, so 35.453 times 3. So the mass of the chloroform is 119.378. Kind of ran out of room there. 119.378. So that cancels out my grams of chloroform and leaves me with moles of chloroform. So step 1, which was convert to moles, is done. I have converted to moles because my grams have canceled out. So I'm going to keep going. Just do it all in one line. Step 2 is set up your mole ratio. The mole ratio is where we put moles of our known substance, CHCl3, on the bottom, and the moles of the unknown substance, which is what we're looking for, CH4, goes on the top. Remember, it's a mole ratio, so it's moles over moles. And the numbers that go here come from our balanced chemical equation. CH3, the coefficient is 1, or CHCl3, the coefficient is 1, so I have a 1. CH4, the coefficient is 1, so I write a 1. Alright, so now our moles of CHCl3 are going to cancel out because they're on top and bottom, and I'm left with moles of CH4. So I have converted to moles. I set up my mole ratio. This is my translation step, so I have translated from chloroform into methane. And now I'm going to do step 3. Step 3 is convert to the desired unit. The desired unit here is grams, because it says how many grams. So if I have moles of CH4 here, I'm going to write moles of CH4 here. And I'm trying to convert to grams of CH4. Now, the number that goes here is 1 because it's a conversion, 1 mole. I'm doing a mole conversion just like we did previously. And the number that goes here is my molar mass. Well, again, carbon is 12.011, and I'm going to add 1.008 4 times, and that gives me 16.043. So my moles of methane now cancel out. I'm left with grams of methane, which is what the question is asking for. So now I'm going to do my math. I'm going to multiply across the top, which is 50.0 times 16.043. I'm going to divide by the bottom, which is 119.378. Okay? So, let's put this in our calculator. We have 50 times 16.043 equals 802.15, and then I divide by 119.378, and that equals 6.72, and grams of CH4, the unit that's left here, so grams of CH4. You can't just put grams, you have to put the substance. We have to know what the substance is. So, that is a mass-to-mass stoich problem, all worked out.